Well, I'm not sure exactly what happened there, but the tablet shut off. I didn't get a whole lot into what I was talking about, other than I said I was going to talk about from factoring as a general for the whole chapter a little bit, give you some ideas on that. And then we'll go over 6.1, 6.2, and 6.3. And I think what I'll do is save the links separately. So I'll say one is 6.1, one is 6.2, and one is 6.3. All right. So I'm going to talk a little bit about factoring in general, and then talk about factoring specific to what's in 6.1. So what I was saying is that factoring polynomials, and factoring is sort of thought of as undistributing or unfoiling. Right? So what we're doing is we're taking a polynomial or a expression, and we are writing it in terms of its factors. Okay, so that's what we're doing, and some of the reasons for that is sometimes factoring can tell us a little bit about the polynomial, so that's why we do that. Although factoring doesn't have a lot of uses, it does help in upper level mathematics and certain topics. So let's take a look at this. So we're undistributing or unfoiling. So this is a little bit more specific to the whole chapter. I'm going to write down some factoring techniques. So what I would do is I'm going to refer to these as we progress through this chapter. All right. The first factoring technique that I like to think about is taking something out. Okay, so that would be the first factor strategy or technique that I would look for, is look to see if I can take something out. And I want to give you multiple examples of these. The second one is called the difference of two squares. All right. Number 3, I'm grouping under the word trinomials. And number 4 is grouping. All right, so these are my 4 basic factoring techniques that I'm going to talk about. We're not going to do all of them today because some of them are in the other sections. So the first one we're going to talk about in 6.1 is taking something out, and also a little bit of grouping. And we'll come back to grouping when we do trinomials. There's actually a couple different ways of factoring trinomials I want to show you, and grouping is definitely one of them. So let's just go ahead and talk about things a little bit more specific to 6.1 and this whole idea of factoring by taking something out. All right, so let's look at something simple here. Let's go with this. Okay, so there is a polynomial. We're going to factor this. And what we want to do is we want to find something that divides into both of these things evenly, is the best way to describe it. So we see we have a 3 and a 6. And we notice that a 3 will go into both of these things evenly. And it's best to pick ones that are the highest common factor. So we want to find the one that goes into both of these things evenly, but it's also the largest number, so it kind of simplifies it down. In this case, obviously, it's going to be 3. So I'm going to put my 3 here. So here's where my undistributing comes in. So I would say, okay, if I take this 3 here, this 3x, and I divide by 3, or I'm going to get x. And if I take this 6 and I divide by 3, I'm going to get 2. So that is completely factored, all right, because if we go back through and just use our minds to check that, we see we have 3x plus 6, which is what we started with, all right. So we're undistributing or undoing the distribution, and that's what factoring is. So the answer to the problem is there. Right? It wouldn't make sense for us to go back to 3x plus 6 because that's where we started from. So factoring is actually, again, undistributing. All right, so that's our answer. Okay? You might say, wow, that wasn't so hard. Taking something out isn't one of the more difficult techniques of factoring. All right, so let's try another one here. So let's go with this. All right, so here I have a minus, which doesn't really change anything. I'm still looking for the greatest common factor that goes into 48 and 36. All right, so then I want a large number goes in there. Maybe. I know 2 goes in there, obviously. I know 4 goes in there, obviously. 6 even goes in there. But I think I can do better with a 12. So if I put 12 on the outside, I put a parentheses here, so now I'm dividing. 12 goes in there 48 4 times, goes in there 3 times, and there's my answer. Okay, so that's factored. Again, if I wanted to, I could distribute it back in to check to make sure that it matches up. Okay, that would be a definite check. That'd be something you don't have to do, but if it helps you on taking something out, then go ahead and do it. All right, let's make it just a little bit more challenging here. So now we have an 8x squared minus 4x. So this time, not only do we have numbers that we can take out, but we also have variables we can take out. So this is when taking something out gets to be just a little bit more challenging. So number-wise, I can see that if I take a 4, I'm okay, because 4 goes into 8, 4 goes into 4, both of them go in there evenly. For the x's, I have an x squared and I have an x. Right? So I can see that they both have an x sort of common. And we talked about exponents before. So this is really 8x times x, and this is really 4x. So we can see that we have an x and we have an x. All right. So that's what we're going to take out. All right. We're going to take that out of there. So if I put 4x here, all right, I know I'm going to have a 2 here because 4 goes into 8 twice. This x and this x that I'm referring to that I circled in the lighter blue, those are coming out. That's why I put that here. I'm still left with 1x there, minus 2. Oops, I should be taking a minus 1, sorry. There we go. And that's factored. Okay, again, if you distribute it through there, you're going to end up with what we started with. All right. Let's keep going. So let's try one like this. Okay, so here we have 3 terms. So we want to know, okay, what can we take out of here? We have an x squared and an x, but we have no x's on this thing, so we can't take anything x-wise out of those. So the only number that goes into all those evenly would be 2. So we're going to take the 2 out. These is with 6x squared plus 7x minus 3. So again, we can distribute that through, but we're going to end up with what we started with. So there's my answer. Okay, let's try one like this. Let's go with 18x cubed minus 9x squared plus 3x. So now we have one like that. All right, again, we have another trinomial. We're just taking something out. That's our rule right now. That's what we're doing. That's our procedure. Look at the number. Find that highest common multiple, the greatest common factor, I should say, that you can pull out of there. That's got to be a 3. And now we look at the x's. So we concentrate on the x's. So we have 1x, 2x, and 3x. So the most that we can take out of there is 1. So we take 1x out. And now we're dividing. 3 goes into 18/6. X goes in the air, gives me an x squared. And I can think of that as taking x, what would we multiply x squared by to get, or what would we multiply x by to get x cubed? That's obviously got to be x squared. Minus 9x. Again, what would we multiply x by to get x squared? It's got to be x. And this last one would have to be a 1. And that one's factored. So these are all examples of taking something out. Okay, so let's try another one here. Let's go like this. So here we have 5x squared y plus 10xy squared. Obviously the number 5 goes into both of those evenly, so we're going to pull the 5 out. And the variable side of it, I have okay, so we're taking a 5 out. We're going to take an x out of both of these because x is common to this. Oops. We're going to take a y out also because y is common to both of those. So if I take a 5 out, obviously I'm going to get a 1. X from x squared is going to give me an x. Y from y is, again, there's nothing there. That's just a 1. Plus 5 goes into 10 twice. X leaves me with a 1. Y goes into y squared once, gives me 1y. And there's my answer. So that one, it's a little bit trickier. You know, we got the numbers probably, you can see that pretty easily. The x squared and the x, again, that's just like what we were breaking down up here, where I said, well, you got 2 x's and 1 x, so you're going to take 1 x away, right? Same thing with the y's here. It works the same way. So we're taking 1 x and we're taking 1 y, taking that out. If you distributed that back through, you're going to end up with the same thing you started with. So you're just really undistributing. So if you're really good at distributing, you should be able to do the reverse and undistribute. Some of the ones in your assignment are going to be with a negative out in front. So let's say we have a negative 12x squared with a plus here, and we'll make it a 9x like that. Okay, so then we want to take out, again, that largest number that goes into those things. Since this is a negative, it's a, hold on. Okay, so I had a question from a student. So anyway, on this here, we're going to find our greatest common factor, which is 3, but it's negative out in front. So the suggestion is we want to take out a negative 3. So whatever the number is that goes in here, or the term that goes in there, since we have a negative in the lead, we want to take the negative out. So I'm going to take out a negative 3. All right. And then again, I have an x squared and an x, so I know I'm going to take out an x. All right, so I have that. So now when I do this one, I have to keep in mind about the signs, right? Because I know certainly that 3 goes into 12 4 times, and I get that. But because it is a negative 12, I need to make sure that's a positive 4, so that when I do that undistributing or distributing, it works. Here's the same idea. I know that 3 goes into 9 3 times, but because this is a positive, that means this is going to have to be a negative 3 in order for this thing to work. Okay, so when we have a negative out in front, we always want to take that negative with the factor. However, that's going to change the sign here, okay, because we took that negative out. All right, so that's how that works. So we want to be careful with those. So there'll be a couple of those in your assignment, all right, and then as you progress through, we want to be able to just take that negative out of there and do that. Okay, so we took care of all the taking of something out. I don't think you're going to run into anything in your assignment that you're going to see that's going to mess you up that way. I've already covered. The next part of this is factoring by grouping. So in factoring by grouping, let me give you some examples of that. Okay, so here's an example of a factoring. Ooh, I want to make this like this. There we go. A factoring by grouping. Okay. I'm going to change this to all positives. Alright, so we're going to do this one. Factoring by grouping goes like this. So we take the first two and we take the last two and we group them. Factoring by grouping is usually always going to be 4 terms. There are situations where it's not, but in this course you're pretty much going to have 4 terms. I don't know if we'll run across anything that is not 4 terms. So if you see 4 terms, that's pretty much a dead to right factoring by grouping. You still can take something out of it if you want to, if it helps you. In this case, there's nothing we can take out of that thing, but if we could, that would be one of the things we do. We probably want to take something out of it to make it easier for us to factor it. So now that we've grouped this, we look at this and say, okay, what can I take out of these two? I'm not concentrating on the green one, just looking at the red. I see this has an x to the third. I see this has an x to the second. So that means I should be able to take out an x to the second. And then when I take that x to the second out, I know I'm going to have x here, and I know I'm going to have 1 there. All right. So then the next thing I want to do is factor the next part. So I'm going to bring down this plus first. And now I'm going to factor this next part. What can I take out of here? I have a 2 and a 2. I can't do anything with this x because there's no variable there. So I'm going to take a 2 out. And I get that. Alright. So, the important thing is that these two guys are the same. Because when you're factoring by grouping, if these are not the same, then there's a mistake someplace, or you can't factor it by grouping one of the two. So to finish this off, what we do is we do another kind of undistributing move, and it's sort of a, how would you say it, sort of one of those mathematical, I don't want to say trick, but sort of a hand wave, or a, oh yeah, this is how this works. And not a whole lot of people understand what's going on here. But the idea is that we're going to, since these are common, is that we're going to take those out. Alright, so that's what we're going to do. We're going to take the x plus 1 out. If I take the x plus 1 out, and I'm going to write it like this for now. So I'm left with that. And if I think about this, so if I move this whole quantity to here and this whole quantity to here, you see how I'm going to end up with the same thing? Alright, so I'm going to end up with this, and like this. Alright, I don't know why I put an x squared there. Alright, so that's what that's going to look like. Alright, so what I'm doing is I'm taking this common part out. Alright, so I'm going to go x plus 1 there, and then the leftovers are x squared and 2. So it's hard to see a factoring by grouping, but you can get by just saying, look, as long as these two things are the same, I'm going to write one of those and then whatever's left over. Okay, so I'm just going to write one of these and then whatever's left over. So that's a factor by grouping. Let me try some more. Okay, so let's do this one. This one's not a really good example, but it's not bad. So again, we're going to group these up here. Group these ones up here. So I can take a 3 out of this one and an x. That leaves me with x minus 2. Alright, and here, again, I'm going to bring this plus down. And I can take out a 4, which again leaves me with x minus 2. So there's my commonalities. And then I can just put them together. So I'm going to go with the 3x plus 4. and the x minus 2. And that's factored. Alright. What I'm going to do is I'm actually going to stop this recording and save it, and then we'll pick it up in part 2. I want to do some more factoring by grouping, but I don't have a chance to do that right now. So what you want to do to see some more factoring by grouping is actually access the second video after this. Thank you.